Hey, 620 students, this is Dr. Smith, and I'm going to talk to you about technology evaluation in Module 3. So far, we've thought about how we can build community, and then with Module 2, we thought about how we can do launches and how we can get students interested in learning through using technology. In this module, we're focusing more on what kind of activities can we do to help us learn. And that goes with how do we select good technology. And so we're going to talk today about how we evaluate technology. But before we really focus in on technology evaluation, I think we need to think about how we can use technology effectively and efficiently. And I think I have different definitions than what we usually hear in education about what it means to be effective and what it means to be efficient. So thinking about effectiveness, a lot of times we hear about whether a teacher is effective or is not effective. And that generally focuses on whether the teacher's students can do well on an assessment. Effective teachers have students who do well on the SOLs. Well, is that really true? See, to me, effectiveness is not about results. It's not about assessments. It's not about evaluations. An effective teacher is not about these things, because all of these things are products of the teaching. But effectiveness should not be focused solely on the product, but it actually is the work. So effectiveness is not just about the product of work, it actually is the work that we do. Effective teachers do things in particular ways. Now, effective teachers may have these kinds of results we're looking for, but we shouldn't think about effectiveness simply from the standpoint of results. Effectiveness is really about doing things the right way. Effective teachers do what is in the best interest of their students. Effective teachers teach in the right way. They're going to do what is best for their students. Now, effectiveness and efficiency go hand in hand, but again, I think I have a different definition about efficiency. I don't see efficiency as about doing things very quickly. Well, that person's very efficient. They were able to get that assignment done real quickly. Or it's not exactly about making good use of your time. Efficient people usually make good use of the time, but why and how do they make good use of the time? Okay? That's a product of being efficient. Efficient people make really good decisions. They make the right decisions about what to do. Efficient people don't really make lots of wrong decisions where they have to go back and takes more time. Well, that's why efficient people make good use of your time, because they make the right decisions. I think great teachers have to be efficient and effective. You have to make the right decisions on what to teach, and you have to teach in the right way. I know a lot of teachers that are one or either efficient or effective. I know teachers that make great lessons. They make these fantastic lesson plans using great engaging activities. But then when they go to teach it, they teach it like a direct instruction. They never really allow the students to really think. I also know efficient teachers that make really, really, really great decisions about how to teach, but what they're choosing to use isn't very good at all. Now, when we use technology, it even amplifies this idea that we need to be effective and efficient. We need to be able to choose the right software to use with our students, and then we have to use it in a way that's really going to allow them to think and learn. Okay? And that's because when we use technology, sometimes we're giving up some of the control in the classroom. And here's the thing. When we go to find technologies, there's so much out there. Here are examples popping up of different math technologies that you could use with your students. And look at these. And this is just a small sample. There are literally hundreds of thousands of things on the internet that you could use with your students. So how do you know which one's good and which one's not? How do we make those decisions? Too often teachers are Googling something, and if it's not in the first 3 or 4 results, that's it. They're not looking at anything. So how can we make sure that we're using things that are efficient and effectively? So one of the things that came up with is a framework by Dick, who is at Oregon State. He's a math educator, and he had this idea of fidelity. And he designed this framework for people that design mathematics technologies that are supposed to be used to teach mathematics. He came up with 3 different kinds of fidelity. He had mathematical fidelity, whether the mathematics held and was true in the technology. Cognitive fidelity, how did the technology reflect students' thinking? And pedagogical fidelity, was it using good pedagogy? So for us, I don't want to focus strictly on the mathematics because none of y'all are going to be our mathematics teachers. But I think these ideas still hold true. And so instead of mathematical fidelity, I'm just going to put content fidelity. So we're going to go through each one of these, and I'll show you an example of each. So content fidelity thinks about how well does the technology represent the content, and how well do the things in the technology reflect the actual things, rational concepts and the ideas that you want to show. Is it accurate, or are there issues? Does it could the students develop a misconception while using it? And so content fidelity focuses on how true is the content displayed in the applet or in the technology to the actual content ideas in themselves. So we're going to watch a video, and I don't know if y'all are familiar with Motion Math's Hungry Fish. Motion Math is a company that I really like. I really like their applets. And this is called Hungry Fish. I have it on my phone. My kids like to play it. They think it's really fun. It's a way to practice addition, subtraction, and your math facts. Okay, so watch this game, and then we're going to talk about it. Think about how the program is displaying the mathematics and the thinking that's involved.
At Hungry Fish, featuring a fish who eats numbers. In this case, 3. The game also features instant addition. Touch a 1 to a 2 and you get 3. It's an engaging way to practice addition, made possible by multi-touch. To win, you must find different ways to add up to a sum. For example, what are all the ways to make an 8? If you don't feed your fish, it shrinks. Feed it enough numbers, it'll grow, you'll win the level, and you'll get to customize your fish, unlocking new colors and new fins.
All right, so my middle daughter loves this aspect of it, that she gets to put different colors. So let's think about how the mathematics is being displayed in this software. So the way the game works is you have 2 bubbles, and you combine them together to make a new bubble that matches what the fish wants to eat. Now, the example that we saw first was the 1 and the 2. You took a 1 bubble and a 2 bubble, and it makes a 3 bubble. Well, what's really going on mathematically here? Well, you have a numeral, a symbol 1, and then you have a numeral, symbol 2. When you combine them together, you get a numeral, symbol 3. And that may not make sense. And it didn't make sense to my kids who did it at first. All right? Because what's really going on mathematically when we add? Well, we have a set of objects that has a 1 object in it, and we have another set of objects that have 2 objects in it. And so when you combine them together, you get a new set with 3 objects in it. But those number of objects within the bubble isn't being displayed because we're just using numerals. Thus, it just seems like you take one symbol, you take another symbol, you combine them together, and you get a new symbol. And children can't really understand what's going on there. Now, the other way you could do it mathematically appropriate is to have different size bubbles, where you have a 1 size bubble, and then you have a 2 size bubble that's twice as big as the 1, and then when you combine them together, you get a 3 size bubble, right? So that could also be mathematically correct and display the mathematical ideas. So I had this issue with this software program, and a few years ago I was at the National Council of Teachers of Mathematics annual meeting. They have a big display of all the vendors there, and Motion Math was there. And so I went up to them and I started talking about this problem that I had with their software, and they said, yeah, we recognize that, and we were actually making changes to the software. And I said, oh, are you guys going to do the bubble sizes? And they said, well, no, because when you add 2 and 12, you get a 14. Well, the bubbles will be huge. And I said, well, that makes sense. And so they said, look, this is what we did. And I thought, wow, that's really smart. So they made this idea of the sets have 1 object, and the set has 4 objects, and you combine them together, and you get 5 objects. And then they mix the numerals in there as well. So maybe they can make the connection between the numerals and the number of sets in the objects. And so now this has much more content fidelity than the previous game. Okay. So the next type of fidelity is cognitive fidelity, and this really examines and lets you to think about how are students thinking when they're using the program. And does a program allow you to see how students are thinking? Okay? How well does the applet reflect what the students want to do? Because I've seen softwares where students want to do something that should be allowed mathematically or by the content, but the software says, no, you can't do that. So you want to think, does it allow students to do and think in unique ways? So we're going to look at another applet here. And again, I'm sorry, they're all math, because that's what I know. This is also by Motion Math. Again, I'm not trying to degrade Motion Math here by showing some issues. It's just there are some issues with their stuff, but I like it so much that I want them to see them improve. So what this is looking at placing numerals on a number line and understanding, knowing relative size of objects and knowing the order. Okay, this is the intro level as you see, but I want you to think about if this was more than just the intro level, how this would work and how are the students thinking as they're using this software. What are the students thinking about? So what is the student thinking about? Are they really thinking that 11 comes after 10 or 19 comes before 20? I'm not sure. And I'm pretty sure that what they're doing is they're playing find the blank. Where is the number missing? And that's where it has to go. Okay. Now I love this. I really do love this applet. The frogs are actually the units. And then if you zoomed in, they would have it by tenths. And I think there's like some kind of big bug, and then for hundredths there's a smaller bug. If you zoom out, there's actually a dog that gives you the 10 units, and then like a rhino for the hundreds. They do animals to do relative size, and you place numbers on these number lines, and you have to zoom in and zoom out. And so it really gives you about size. It's really a great program, but what are they thinking about here? They're thinking about finding the blank, and that's not really what we want our students to think about. Last one is pedagogical fidelity, and how well does the applet allow students to do? And what I mean by that is, does it allow them to really do the mathematics or do the English or do the social studies? Is it really allowing them to do, or are they just parroting something else? Okay? How does the applet limit their thinking? What kind of features limit their thinking? I know cognitive fidelity seemed more about thinking, but this is about limitations. Okay? And then this one did also, how does the applet distract students from learning? You know, there's applets that look really pretty and have all these things, but are they really learning from it? Does it distract them from what they should be concentrating on? All right, so we're going to look at a game. That's another addition game. They'll put an addition problem up here on this moon, and the student has to solve the addition problem and use a slingshot to do the answer. You'll see. Oh. I like this one. Almost. Oh, I lost. So what about pedagogical fidelity with this? What are they really learning? Are they really doing the mathematics? Well, they're solving this problem up here. He had the answer. It was 3, right? Yet, he didn't score. He couldn't get to the 3. So what is he really learning? What is he really doing? I can say that he's probably learning something about physics and maybe something about slingshots, but is he really learning mathematics? Not really. What is the goal of using this, and is it allowing students to really think and do and learn mathematics? At least in this case. but in other cases it'll be just the content. Okay, I put a reading up on the course Weebly and on D2L. It's a reading about evaluating technology for teaching mathematics. You do not have to read this. It is an optional reading. There's a couple middle school math teachers or soon to be middle school math teachers in the class that might find this really useful. It is unpublished. It is set for publication. I thought maybe it would be coming up in August, but I think it's going to be pushed back. But I put it up there. You can't cite or distribute this until it's been published, but yeah, I think you guys will get something out of this. And it may be helpful for your assignment. So, on the course Weebly, there's an assignment that I want you to do. I want you to use these ideas fidelity, even if it's changed. You're going to explore, analyze, and evaluate 4 different technology tools that could be used to teach the same topic. Okay? So you're going to use the fidelity to analyze and evaluate 4 tools that could be used to teach the topic. And so one of the topics, areas, is area and perimeter. You can choose that one. Or you can choose to use one on verb tenses. I found 4 online games and applets that can be used to help students learn verb tenses. So you're going to pick one area. I can't use that word. One content. One set of content. You're either going to pick area and perimeter as your content, or you're going to pick verb tenses. And for each, I have 4 applets. So what you're going to do is first you're going to create your web page called Techno Evaluation, and it should be under the Instructional Support tab. And then on the web page, I want you to evaluate each of your 4 tools within your content type, okay, using the 3 fidelities. I want you to include a screenshot of each of the tool, and then I want you to do a description of the features that you think are beneficial and those that you think are drawbacks, and use the fidelities to help you also think about those things. And then you need to explain why, and the explanation is always more important to me. You need to be able to support any claim you make. And then once you're done with that, I want you to write a comparison of the 4 tools, and you should examine and discuss the feature of the tools that you find particularly important, right? You know, there's features that you think are really nice and neat, but are they really important to making this decision? So then I want you to state which tool you would select, and why, and explain why. Your selection. After you're done with that, then go over to Flipgrid and do a Flipgrid, and I have one question for you. Just tell us which tool you chose and tell us why. Okay? You have 90 seconds to do that, and then once you're done, then I want you to respond to at least 2 classmates' videos. You may need to go find other classmates who did the same type so you can respond. All right, that's good. That's it. Happy evaluating.